Okay, let's be honest. When you hear the word algebra, what's the first thing that comes to mind? For a lot of us, it's, confusing math class. But what if we try looking at it a different way? What if we thought of it not as math at all, but as a language? A really simple, super powerful language that, get this, you might already know the basics of. Seriously, let's dive in and see how.
So, remember solving puzzles like this back in school? I bet this looks super familiar. It's probably one of the first real math puzzles any of us ever tackled. But here's the crazy part. What if I told you that this little empty box, yeah, that box, is the secret key to understanding all of algebra?
Right? In those early puzzles, that empty box was just, well, it was a placeholder, wasn't it? It stood in for a number we had to figure out. It represented some unknown value. So if you had, say, 2 plus something equals 10, you instantly knew that something had to be 8.
And check this out. The moment you solved for that box, you were already doing algebra. Yep, you were using the core, fundamental idea behind it all, using a symbol to stand in for an unknown number. It's a skill you've literally had all along.
All right, so here's our game plan for today. First up, we're going to see why we made the jump from simple shapes to letters. Then we'll get into the basic vocabulary and grammar, the stuff you need to get fluent. And to wrap it all up, we're going to find out where this language pops up in the world all around us. It's going to be great.
Okay, Section 1, from shapes to letters. We're upgrading the code you already know. So really, why did we ditch the shapes? Well, it was all about making the secret code we were using way more powerful, and honestly, a lot less confusing. Look, shapes are fine for super simple problems, but they get messy fast. Think about it. If you see a square and a diamond in the same equation, do they have to be different numbers or can they be the same? It's kind of ambiguous, right? But with letters, it's crystal clear. An X and a Y can stand for two totally different values. Letters just give us this amazing level of precision that shapes can't even touch.
All right, on to Section 2, the vocabulary of algebra. We're learning the key terms. So now that we're on board with using letters, let's actually learn the vocabulary. Just like any language, there are a few keywords we need to know before we can start building ideas.
And the number one most important word is variable. It sounds fancy, but it's really not. A variable is just a letter that stands in for a number. That's it. So instead of our old empty box, we now use an X or an H or whatever letter we want. It's the exact same idea. It's a placeholder. It's just way, way more flexible.
Let's make this real. Imagine we want to talk about the average height of students in a classroom. Now, we could write out the average height over and over again, or we could just use a variable like h. It's a simple, elegant shortcut, so much easier. So, once we have these variables, we can start building phrases with them. And in the language of algebra, we call these algebraic expressions. They're just a mix of our variables, some numbers, and operation signs like plus or minus. So for example, h plus 10. What could that mean? Well, it could represent a student who's 10 centimeters taller than the average height, h. See? It's like a little sentence. Okay, let's move on to Section 3, the grammar of an expression, or how to write algebra the right way. Now, every language has grammar rules, right? They're there to make sure we're all on the same page. Algebra is no different. But the cool thing is, its grammar is beautifully simple and it's all designed for one thing, making things as clear as possible. And there are really just 3 big rules. First, we drop the multiplication sign. So instead of 2 times h, we just write 2h. It's so much cleaner. Plus, it avoids any confusion with the letter x being a variable. Second, the number always goes first. We write 2ab, not a2b. It just keeps everything consistent. And third, we use powers for repeated multiplication. Writing h cubed is way faster than h times h times h. See? These aren't complicated rules. They're just smart shortcuts to keep the language neat and tidy. Okay, so let's put this new grammar to work. We're going to take some regular, everyday English phrases and translate them into these clean algebraic expressions. This is where the magic really happens and it all starts to click. Just look at how powerful this is. A phrase like, a height 12 centimeters shorter than average. That just becomes h minus 12. Simple. What about a height twice the average height? That's just 2h. Remember our grammar rule? No multiplication sign needed. Algebra takes a clunky English phrase and turns it into something super elegant and concise. And that brings us to our final section, algebra in our world. And this is all about why this language matters.
Because you might be thinking, okay, this is cool, but why should I care? Why learn this new language? Well, it turns out this is so much more than a classroom exercise. This is the language used to write the actual rules of the universe.
No, I'm serious. From biology and chemistry all the way up to the motion of planets, algebra is the tool scientists use to understand the world. It gives us a way to describe the relationships that govern everything around us with a kind of precision that plain old words could never, ever achieve.
And you see it spoken everywhere in science. In biology, it's used to model how populations grow. In chemistry, it expresses relationships between stuff like mass and volume. And in physics, well, in physics it's everything. These algebraic formulas are like these tiny, super powerful sentences that describe how the universe works, from the smallest atom right up to the biggest galaxy.
And this right here might be the most famous algebraic sentence ever written. F equals ma. Just 3 letters and an equal sign. It's so simple, so elegant, and it completely changed how we understand the world.
This, of course, is Newton's second law of motion. All it says is that force is equal to mass times acceleration. But it's so much more than just a description. It's a tool for prediction. If you know any 2 of those values, you can figure out the third. You can literally predict how an object is going to move. That is the incredible power of this language.
So just take a second and think about the journey we've just been on. We started with a simple shape in a box, a kid's puzzle. And now, just a few minutes later, with a couple of new rules, a tiny bit of vocabulary, and some grammar, we've basically unlocked the language that describes the fundamental secrets of the entire universe. That's pretty amazing.
So I'll leave you with a final thought. Now that you know the alphabet and the grammar, what other parts of your world could you describe using the language of algebra? Whether it's figuring out your monthly budget, scaling a recipe up or down, or even just understanding a news report, the relationships are everywhere, just waiting to be described. So now that you know the language, what are you going to use it for?